Hello, everybody. Welcome back to track 3 of the third and final day of Python WebConf 2020. My name is Josh Qualls. I am the Community Partner Manager here at 60 Up, and I'm joined by my good friend and fellow 60, Caleb Gosnell. Caleb, I'm more or less just going to let you take it away, but before that, I want to make sure that I remind everybody, if you have any questions, put them in the Slido on Loudswarm or in the track 3 channel in the Slack workspace, and I'll make sure that Caleb gets those answered ASAP. Without further ado, I will get out of your hair. Caleb, take it away.
All right. So I imagine now people are seeing my face, which is exciting. I want to take a second right off the top here and thank you, Josh, for the work that you're doing, putting this on. Also, Mary Beth, I know like you've been doing a lot of critical work to make this event happen. And also our intern, Elliot. He's had to do a lot of data entry and other things that I personally would be loath to do myself. So that's great. I also would like to thank the people who are steering the ship over at 6 Feet Up for making these kinds of community events a priority. It's really important to me, a member of the indie tech community, that our company can participate in the way that we do. Okay. So today I'm going to be talking about software deployment, how I personally think about it, popular patterns for doing the job, and some of the issues you'll want to consider when it comes to implementing a process of your own. So you'll probably get the most out of this session if you are just getting started in application development or operations, or if you're looking for clarifying first principles for approaching the subject. Because sometimes it's just hard to think about. Or if you're feeling pressure to hop on the latest trends, there's a lot of like fear of missing out that like could be going on, and I wanna give you some information about it. So our agenda here, we'll finish up this like preliminary bit. We'll go through a generic model that I've just sort of made up, like thinking about like what is this. And then we'll step through some sets of common practices that correspond to like the steps of this model. And then we'll review some example workflows, and then we'll finish things up with a summary and like some things to think about. So my name is Caleb Gosnell. I'm a DevOps engineer at 6 Feet Up. Since 2008, I've been working in operations, which can be kind of an unpleasant job if you're not doing automation. Around 6 years ago, I started heavily using Ansible. And at this point, I'm using like Salt and Terraform, and a lot of the work that I'm doing is in AWS. So with that sort of idea about who I am, we're ready to hop into my cool hot take on web deployment. So this is the whole model. There are 3 steps. There's a build step, a ship step, and an evaluate step. In build, you take some actions to make a thing that you can ship. There can be like several things that happen in build, but like the whole idea is then afterwards you have a thing that you can ship. In the ship step, you're ultimately just going to be running the thing that you built, right? There can be like any number of things that happen like inside of that, but the takeaway is you're running the thing that you built. And then in evaluate, you look back at what you've done and you decide whether or not you like it. You think about how that went and you choose what to do next. That's as plain as I can make it. So here's something that I sort of working this up realized, like if this is the model, then like nearly everything is deployment. So if you're doing your local dev, right, you're interacting with, and like you've got like your local server started up and you're interacting with that, like did the changes that I put in accomplish what I meant to, right? You're on the evaluate step. After you go back into the editor and start making code changes, right? You have maybe an integrated linter in your IDE. You've got a syntax validator, right? Those are doing build. And once you save that, shut down your instance and relaunch it, right? You've just shipped new code to your user base of one, right? And then you can go to the evaluate step, see if it's working the way you want, see if there's changes that you need to make. In a dev server environment, right, it would work a little differently, right? You probably have the source code in a repository, and you could have a CI job that like bundles that up into a tarball, right? Well, it unpacks it, installs dependencies into a virtual env, bundles it into a tarball, copies it over to a server, right? So like you've built it, right? You're copying it over to the server, you unpack it, you start up the WSGI server, right? So now you're running the thing that you built, right? Ship has been achieved. And then the CI process could go on to carry out some integration tests, right? Like, is it running the way it should? And like that information gets communicated back to the, right, whatever like interface is managing the CI process, right? Yeah. So the story for prod is similar, except instead of just like the automated tests and your QA department that's looking, the things that are doing the evaluation are your monitoring infrastructure and your end users. And any of the DEF CON attendees that are out on the internet and interested in your site. Yeah. But we also need to remember that while everything can be deployment, like looking at it through this lens, deployment isn't the only thing out there, right? Deployment exists within the software development lifecycle. The software development lifecycle, like this is not a new idea. And I wouldn't be surprised if many of you were already familiar with this, but we're gonna go ahead and walk through it. If we start at the application and infrastructure stakeholders, right? These are the people who like they had an idea for an application, and right, that it's been like built, right. Well, yeah, it got built in, they specified the design, user requirements, right? It got built, and then like the output of that built got like ran. They decided to make some changes to it. Right. Eventually, you follow this whole pattern of like you think about what you want to do, you do the thing, you run it, you look at how well it's working, and then you decide to make more changes. Yeah, but the software development lifecycle isn't the end of the story either, because there is the whole rest of the universe going on simultaneously, right? Your application's lifecycle process is just one element of your organization's many competing concerns, and your organization is just one of countless organizations that are out making changes in the world. So, so that is how this model of deployment is related to all of the activity of all the people in the world right now. So we can now take a closer look at some of the things people do specifically for the build step. The build actions can execute in a number of places, right? We mentioned a CI server or a repository service, right? I mean, if you've got a GitLab, a GitHub, a Jenkins box, right? Like those have the capability to carry out these workflows that you've specified. With a good IDE, which I believe there are some people in the Slack with a channel dedicated to good IDEs, you can have processes refining your code, right? Like preparing it for build while you're actually still writing the code. You can also have like Git hooks that perform actions at build time. So some of the things that are commonly done, are static analysis, which a static analysis tool like takes the source code as input and outputs judgments or suggestions based on like that tool's understanding of that language's syntax. An excellent example of this is linting, right? It looks and tries to make the source code fit the formatting standards, right? Is the white space in the right place? Are your lines more than 80 characters long? Examples of things that can carry this out are AutoPep8, PyLint, and Black. There's like automatic error detection, which you can think of as like linting for errors, right? It takes a little more understanding of like what would cause an error in the runtime. Tools like PyFlakes, PyLint, MyPy could find things for you like, oh, if you've got unmatched square brackets, right, that's going to be a runtime error, and these will in your IDE, or like ran standalone in a CI job, will prevent those errors from taking down your actual site because they execute before you've shipped. There's a vulnerability checking, right? Safety. There was a great talk yesterday about libyear that right, look and see like how old are your dependencies? Are there known vulnerabilities against them? There's unit testing, which executes, right? It makes sure that your modules are giving the correct outputs for the expected outputs for the inputs. Unit test, PyTest, hypothesis are examples of things that can do that for you. There's a manual code review that can happen during build, right? If you submit pull request, right? Like either maybe before, probably after like the static analysis stuff, the vulnerability checking happens, right? The value of manual code review is like you can collaborate with your peer about like the approach to the problem, and some of these like tools that can run in an automated way can prevent you from having to like have the discussion about like, is this even going to work? You can talk about like how it will work, whether it's the right approach or not. Semantic versioning there's a specification. I would encourage you to go and look at it. But basically the number, right? Version for software is like the first number is the API version, right? If you make an API breaking change, you have to raise that number so that like when people just looking at the package version can know like there's something different about this. I can't just install this new one. The second number indicates a feature add that that doesn't break the API, and the incrementing the third number indicates that there was a bug fix, right? It's a different version, but it's not meant to actually change any of the behavior. So then packaging, right? This is like the thing that you like, of course, packaging is a thing that happens in the build step. But depending on your application, your infrastructure platform, that's going to determine like how you actually execute your packaging activity. Oh, so some good attributes to have in this step are having a single artifact for every environment, like not specifying the thing, specifying like environment variables and like building it in. Those you can provide at runtime is nicer to do, and saving these build artifacts in an immutable way. Like once it's built, it's not going to change, right? If you need to update it, you make a new one, right? And then distribution, right? You can put these things that you've built in a place where the people that you need to be able to get to them can, and those who shouldn't be able to get to them can't. So that covers build. The ship step here. So once that we have some things built, what do? We ship. Let's take a crack at that. So where the shipping activity executes, right, is also like highly dependent on your requirements and the infrastructure platform, right? It can run on a CI server from your repository service, right? Through a configuration management service, your infrastructure provider. You could run things locally. So the things that are often done in the ship step is you can have an infrastructure as code ad hoc environment, right? You can run code to create the environment that you're deploying in on a use it once and then destroy it later approach. And other things you might need to do are prepare the infrastructure, right? If you're not doing you're going to build it purposely for this one execution. You might need to like go in and like clean up a testing database. If the previous, you don't want to assume that the previous job dropped all the tables that it created. So maybe you have a routine that drops all the tables before something gets stood up, right? You can need to provide secrets, right? If you have left out the like environment specific configuration information from your build, you need to provide that when the system starts up. So you can provide secrets and configuration data during the ship step, right? Obviously, like the launch, right? We're gonna like unpack a tarball or do an instance launch in a platform, or just like check out and start executing the new code. Another thing that is good is a health check, right? If you have in your application a status endpoint that when you hit it, right, like the request only returns after it's like ran a Redis queue, hit the database, right? Right, like whatever underlying infrastructure that your site depends on, right? If you just hit a static HTML page, you can say, oh, the site's up, but it doesn't actually tell you that all of the features are going to be working. So you could have a purpose-built health check URL for that. Oh yeah. Also, like after you get the new thing running, you need it to start serving traffic. So redirecting traffic to the new release is like this is where the rubber hits the road, and we'll cover that in more detail as we go. So another thing that is a good thing to do is have a plan for rolling back. Right, sometimes that's a specific roll undo step. Or maybe what you plan for is to roll forward, just like march on. You could go either way with that. But there are a lot of ways to do the traffic redirection step, and that is normally at a level like where I don't expect most Python developers to have spent time working on like the platform dependent, like the networking stuff. So we'll step through those real quick in the patterns there. And some of the benefits. So the first, like most straightforward thing here is just like you've got one server, you stop the application, you tear it out, you install the new version, you start it up again. There's one major downside, which is that while you have after you stop and before you start it again, like nobody can hit the server. There are some situations where that's fine, like in your local development when you're running your application for testing, right? When after to release your new changes, you have to restart the server. During that restart, you've just done a deploy. The next thing we can do is swap the IP or the DNS values. The pros of an IP swap is it's a pretty straightforward change, right? You're taking, you're deploying a new server into the environment beside the old one, right? The new one has the new code on it. If it starts up and looks good, you can like remove the IP from the old one, put the IP on the new one. That will cause a blip because you wouldn't want to add the IP to the second one first, because then they both have the same IP. And the network layer doesn't appreciate that. But if you're in a situation where you're natting that IP, right, and it's like something in the software that's saying this IP goes to this machine, then you can like with AWS Elastic IP, you can just move those from machine to machine, and you don't suffer downtime from that. The other option in this category is you just change DNS. Right, like the site for the domain like was being served by this IP, now it's being served by that IP. The main downside there is you don't really control like when the cutover happens. It happens like anytime in like the DNS cache lifetime. So that has pluses and minuses there. The next we'll cover is a rolling update. The idea with this is you have some number of machines that are running the old code. You put in one new machine running the new code, and after it's up and live, you tell the load balancer, hey, instead of sending traffic, well, we'll start sending traffic to this new machine, and then it does that. So that's what's happening in time 3 right there. And then you also tell the load balancer, okay, you can have one of those old machines stop serving traffic, and then you're free to take that one out. So then you just keep doing that until you run out of things running the old code and you have only things running the new code. There is one caveat here, which is if your application requires on any sort of like local cache, like if it's got like a big like disk cache that it wants to fill, or if there's a local Redis instance that isn't shared like by the whole cluster of servers, right? You might need to execute some specific queries to warm that up. Otherwise, you're taking like a bunch of things that are warm and replacing them with things that are cold. Your site is going to get real slow until those caches have time to get built back up. So you might have an artificial set of things to run to make that happen. So the next strategy for swapping which version of your application is running is this blue-green deployment. This gets a lot of attention in the like container space. So you can think you have like one set of capacity that's like the blue capacity, and you also have the green capacity, right? Or can pool, right? You've got the blue pool and you've got the green pool, and what you would do is put all of your machines. You would launch a set of machines into the green pool with the new code, and then in the load balancer, in the network layer, say to the thing that's controlling where traffic gets proxied to, have it start using the green pool rather than the blue pool, and then you're free to deprovision the bits from the blue pool. A big advantage of this over the rolling update is in the rolling update, you have like 2 versions of your application code running at the same time. So you, if there are database differences in what like the application expects, let's say like you've renamed a database column, right? In V1, like this, as soon as you update that database column, V1 is going to stop working. But if you don't change it, V2 won't work. In this model, like you can like conceptually think about V1 and V2 aren't running at the same time, but you'll also have to allow for the database update, right? That's may not be instantaneous depending on, well, I mean, you can have a transaction commit, but so there's some caveat there, but the main benefit of the blue-green is you don't have like the potential of requests being served like willy-nilly by 2 different versions of the application. a version that's similar to the blue-green, but also a little bit nuanced, is the Canary Pattern, where you have, right, your two separate pools, right? You've got the old machines that are already running, you launch a set of new machines, and then the idea, there's, I don't know if it's folklore or if it's like actually true, canary in the coal mine, right? There are people who would like go into tunnels like to like get coal. They would bring a little bird in a cage, and if there was an air quality issue, right? The idea being like that, like the bird is breathing the same air as the workers, and if they're, yeah, in the event of like low oxygen or some sort of like toxic air, like the bird would die, the people would notice, and then the people would leave. So this canary, right? What you're doing is you're spinning up like the new version of your app beside the old version of your app, and then you are in the network layer choosing to serve people from the new version, and those people are the canary, right? You to make this work well, you need to have sort of a sophisticated load balancer that can say like, well, 10% of the traffic goes over here, but then also you need like the metrics analysis framework so that you can see like, well, are the people on the new version getting the same like rate of errors? Are there particular problems that are occurring in our canary traffic that aren't occurring in the old version? And over time, you just sort of ramp up the, right, assuming like all signs are good, you ramp up how many people are getting the new version until there's nobody on the old version, and you can remove those. A/B testing is this next networking pattern here, where, yeah, this is a little interesting because it's not necessarily for doing a cutover, for doing a deploy. It gets talked about as like doing research for like marketing research or like user interface research. They want to find out like which color of a button makes people buy more pretzels. So what you would do in this case is have sort of a blue-green deploy situation, right? You've got V1 up, right? You install V2, then you configure the load balancer to send like some number of requests to the V2. Maybe the requests it chooses to send to V2 are things that it have been selected because you have like metadata about the users, and you want to only people over the age of 65 get V2 because you want to see how that demographic interacts with this change, or some kind of thing like that. But you need a really sophisticated like user tracking apparatus so that you can know like which clicks are coming from who, and sort of like make it valuable for learning. And then the last of these that we have to discuss is feature flags. So the idea here is instead of doing like all of the work of like standing up new containers and like registering them with the load balancer and like all of this shuffling around, it's fewer moving parts, simpler to have a shared storage area where you set a bit, right? If this bit is 0, like this feature, like as far as the application knows, it doesn't exist, right? When a request comes in, hey, I want to do this thing, like, sorry, that doesn't exist. If you flip this bit to 1, it's like, oh, I've got it right here. It's like, let me open the door and let you in the back room. We've got things that you can do here. So like you can also have like with this pattern, right? Like use the user information that you have, right? The metadata about user sessions to like select who actually has access to features. This is called gating, but yeah. So like you can do this to turn features on or off. Like you will, yeah. But we also need to recognize that the features have to be shipped like still, right? I mean, the code has to be there to be executed. So there's probably something that you're going to have to do, like deploying rolling updates, right, underneath of this, right? This is an application level like behavior rather than what is a deployment artifact level. But yeah. So that takes care of shipping. So the last step of this model is evaluate. Evaluate is a huge opportunity to get low-level and high-level input about the value that your organization is deriving from running and managing this application, right? This happens like on your CI server because like the tests executed. It happens in the brains of all your users because their eyeballs are connected to their brains, and sometimes it makes them write you emails about, oh, I wish this were different. And then there's external systems like your monitoring. So the practices that occur here are like a component of the evaluate step can be as a continuation of your testing workflow, right? Like pushing the information of how well a certain version did on the tests, like to the places that need to know it in order to like queue up the changes for later releases, right? Your monitoring infrastructure, right? You can execute security assessments. You could conceivably hear back from third-party API providers if one of the changes that you made was removing the throttling to their service. They might have questions for you about what you did there. You can use key performance indicators to like isolate and track specific items that are correlated with organizational value. The critical piece of this is to communicate what you've learned, right? We need to pass automation back to automated systems, right? It needs to go to the people involved in the software development lifecycle, like planning. You need to give information to your support personnel or other user-facing groups, right? Leadership can need to know about what's going on with these things, right? It's this like top to bottom process of like understanding what works, what hurts and needs to be changed, how good is something, how bad is something, and always like what can we do to improve. So let's put some of this together with some example workflows. I'm gonna probably try to speed up a little bit and walk through just the interesting bits about these. So first we have the Microservices Entrant, right? These folks are using a local Docker dev, right, with the linter in their IDE. They're doing a Docker build, right, to like run their tests. They're doing Docker Compose up, right, to interact with the software that they've shipped to their machine, and right, doing just like a development workflow to make the changes that they think they need. After that, they're pushing their changes in their Git repository, where a CI system is picking it up, like it's doing a dependency scan, the Docker build, and pushing it to a Docker repository. Then that same CI job goes on to call their their popular container platform to provision a new testing environment, right? That's been specified in infrastructure as code, right? It's got all the details of the setup that needs to occur to run the tests, right? And then in the evaluate step, right, the CI job goes on, runs all of the tests against this thing that's running, and the integration tests are required to pass. If not, it kicks out an error like, oh, the integration tests failed. The performance data is required to be within given ranges. Otherwise, it's like, oh, like the tests passed, but it didn't work well enough because we have performance constraints, right? And then, right, all of that goes, there can be an automated deployment to pre-prod where like there's no build step because you already have the image waiting in the container repository, and the scheduler would receive, and like the container platform is taking care of doing a blue-green deployment for you. And all of the monitoring goes into like, the rest of their like management workflow. So these folks are using a lot of the stuff that we mentioned up above. They believe wholeheartedly that they're harvesting all the benefits of their investment in that setup and maintenance of this process. The next scenario we have here is the weekend warrior. They're just doing this like software side project. They're running right their local Docker build, Docker compose, but when it comes to actually deploying, they're just doing a git push to their platform as a service provider. The platform as a service provider is handling all of the staging and deployment details. So this person has just like outsourced like all of this effort to the paths, which is happy to do that work for them. The third and final of these scenarios we have is Unseen University. Unseen University has multiple sites that use a content management system that requires database connections, file storage, and custom compilation. These folks have built-in, or right, they're running, instead of Docker, they're using Vagrant virtual machines that get the code from shared folders. They've got Vagrant, they run the Vagrant up, which creates a disposable environment for them. The Vagrant kicks off a configuration management tool, which sets up all the other machines also in Vagrant, and deploys the CMS by running its like configuration and compilation script, right? If this is all working great for them, what they do is push their code to the Git repository, right? And from there to ship this, they are using their configuration management tool to execute a workflow, right? It's time to do the deploy, right? We've had our meeting, we've approved our changes because we did a review. Let's go and do the deploy. They log into this thing, kick off this process, and it does a rolling update, and that workflow executes like running the configuration script, adding the thing back into the load balancer, and evaluation of the dev server is manual from within like the QA department. And then they use the same thing to deploy to prod, except that only happens within like their specified maintenance window. So these folks have implemented just enough automation to accommodate all the requirements of their application, and the infrastructure that's supported by their IT department, and like also fits the control model, right? The change control model that their institution requires. So that's time for some wrap up. So it's not hard to imagine how how poor deployment management can hurt your reputation and your feelings and make you lose money. There's substantial evidence that indicates that the practices we've covered here can make deployment provide higher levels of value and enable a virtuous cycle of building you build confidence in the process, so then you're comfortable running it more often. And then because you're running it more often, you're interested in automating it to make it easier and faster to do. And doing that automation reduces inconsistencies in it, which means like you're more comfortable with the process. And so like these values just sort of build on themselves. But there is some or at least the potential for internal conflict between these values. For example, like there's one, you can have one API test case that like, well, it doesn't like, it's an edge case, and it takes a long time to run, so we'll disable it. So you can't just say do everything and it'll be great, because what you have to do, well, it all comes down to the price of the time and the effort that you have to put into it. It takes active management at a technical level and also an organizational level to ensure that your priorities are lined up. Which brings me to, you might have noticed that I have not defined CI, continuous improvement, or continuous deployment, continuous delivery. The tech press has a lot of crowded opinion pieces, or it's crowded with opinion pieces about like what the new and the right thing to do is, and how to find out whether or not you measure up. And I don't want you, please don't trouble yourself over these things. This slide has this maturity model that goes from base, like through intermediate to advanced to expert. And this is falsely implying that if you do everything in the far right column, right, then that's the ultimate achievement, and you can like hang your head up and go home. And that's not true at all. I think like real maturity is having the self-awareness to know which things are important to you, which things are worth putting your effort into, and which things you can let go. What we all just have to understand what resources we have at our disposal, what our requirements are, and we need to balance the trade-offs in a way that works for ourselves, works for our organizations. We have to understand who we are and what we're trying to accomplish. So there's several kinds of organizations. There's several reasons to run web applications. There's many types of applications with their own distinct requirements, right? There's gobs of infrastructure platforms and capabilities that exist. There's only one you, there's only one your organization, there's only one your application. So you need to work with your peers and consult with your community at the Python Web Conference, and your local area, and right, to develop something that works for you. So also, don't forget, you want to avoid leaving stale data in your integration environment. You want to accommodate cache warm-up times. You want to look for partially undocumented dependencies. You want to watch out for not making incompatible database changes by like staging changes or understanding which versions are going to be running simultaneously. You need to prevent cache poisoning. I'm sure there was something in the green, blue, or the rolling update where I was supposed to mention, like, if somebody puts something in a cache and it's in a certain format, but the old format doesn't like that, but they're using the same cache, somebody's going to get invalid data, and that'll be a sad day. So you want to prevent that. And you also want to monitor for runaway processes. If you have a job that is set to retry and infinitely, and it fails every 5 minutes, and your service provider charges you an hour's worth, right? You always pay for the first hour, and then after that is incremental. Then like a thing that fails is going to cost you, in retries and fails in retries after 5 minutes, it's going to cost you 12 hours worth of work in a single hour. Yeah. Also, get your stakeholder buy-in. You can't like go this route alone unless you're that weekend warrior, and you have like total control over everything. Yeah, it's important to collaborate. And then finally, I believe in you. You can do this. There's a lot of resources out there. You don't have to reinvent the wheel. You can start with the easy stuff, right? Notice the things that waste your time and steal people's productivity. Work on those things first. You can feel good about when you do something that saves people time. Of course, use and share open source community tools. And with that, we're all done. If you want some information, oh, hey Josh, you're back. Oh, okay, you're back, not cutting me off back. Great. So this slide is it's a bunch of links. It might actually be too small for you to read, but I'm sure these slides will end up being public wherever we publish them. Some of these things are from my life as an operations person. Some of these things I found specifically for writing this talk, and just background information. But I'm done and ready for questions if there are any.
There are. So before we get to that, make sure everyone that you give Caleb a round of applause there in the Track 3 Slack channel. We always want to make sure that we show some love to our speakers. Sorry, I seem to have kind of cut you off there. No, I was just popping in because I know you were wrapping up. Sorry about that.
Yeah.
We do have a question here. So it's kind of a little bit bigger question, but if you had an unlimited time to set something up, what would your ideal tools / process for deployment look like? Let's say it's a Django app and then one of these.
Mm-hmm. Yeah. So if I had unlimited time to set up a Django app, I would probably rather spend unlimited time watching The Office or playing video games. So I think I would spend a reasonable amount of time figuring out like how important is this Django app to the people who are going to be using it, and like how much do I personally care about it like being a success. So in terms of tools, oh gosh, yeah, it's hard to say off the top of my head. But there are some things I mentioned. Yeah, you actually probably want to do reading about it and fit it to the world, because unfortunately the world, we don't have infinite time.
Sure. Yeah, I mean, you made a great point also that, obviously your needs are kind of, your needs, right? They're not, there's not one, package kind of fits all. So kind of evaluate and, get as many options as you can and figure out what works out for you. So that's definitely some really good advice. I know we've run over a little bit on time here, but I know that we have the breakout room, and I'll make sure to post that link there in the Slack. Again, Caleb, it was a pleasure. Thank you so much for talking.
Happy to do it.